everyone. In this video, I'm going to go over how to do an exponential regression to figure out the growth rate of, well, in this case, an investment, but it doesn't really matter what's growing. So first of all, let's read the question. We'll go over why exponential regression is correct for this question, and then we'll go over the mechanics of how to do that on a Texas Instruments graphing calculator. Sadie invested $24,000 in the year 2028. Returns for select subsequent years are listed below. Use an appropriate regression to determine the average return Sadie achieved over this period. Then there's, some years. They don't go up 1 year at a time. You'll notice that there are some year jumps, which is okay. It looks like it's every 3 years. And then the investment value grows, starting at 24,000. Then there's a hint here. Raising a base to 2,000 plus introduces very high error. Define your first year as x1 equals 0. And calculate the number of years from there. So this is because, even if you have something like 1.01 and you raise that to the 2000, 1.01 raised to the 2000 gets quite ridiculously big. So that's $1 that we started with. In 2,000 years at 1% interest rate, $1 grows to be $440 million, right? So you don't want to raise your base no matter what it is to huge exponents because you end up with crazy big numbers. So we're going to start by redefining that as year 0. And then hopefully you can do this math in your head that 31 minus 28 is 3, plus another 3 to 34, plus 2 in this case. Plus another 3 in this case. So this is year 0, actually I guess I'll fill it in the box. This is year 0, year 3, 3 plus 3 is 6, 6 plus 2 is 8, and 8 plus 3 is 11. Okay, so we're going to use those numbers for our years, just to make sure that our numbers don't get crazy high. So what we're going to do is we're going to go into, I haven't talked about why exponential regression is correct. Actually, let's graph it first, and then let's look at it, because sometimes the graph can help. If you aren't sure, you can always, graph your data and go from there. So year 0, 3. The reason I'm graphing first, in this case, I know it's exponential regression, but often the shape of the graph you get can give you some hints about which type of regression you should be using. So if you ever aren't sure, then graph it, right? Take a look at the graph, and if you know your functions really well, then the shape of the graph can give you a pretty strong indication it can narrow it down to at least a couple options. Okay, so we got that. So now I'm going to do, to get there, I sort of jumped right into this. On the stat menu, the first option is edit, and that's how you get into this list. Now, if we go to graph right now, we get nothing. We just get our, 0 to 10, positive, negative. Graph with nothing on it. You need to turn on your stat plot, which is second function stat plot at the top. Go into our first stat plot and turn it on. And the default options are fine. My X list is in list 1. My Y list is in Y2. And I want a scatter plot, no box and whisker chart or whatever those things are. So that's cool. So then now if I go to the graph, my stat plot is on, but there's nothing there. And that's because our values are way up in the 24,000s and stuff. So what we're going to do is we need to go to zoom, and then option 9 is zoom to your data. Okay, so that is our data plotted out, and you can see it's growing. So what curves do we know that grow? Could be parabolic, I suppose, could be quadratic, or it could be exponential. So let's talk a little bit about investments and why it's actually exponential. So exponential is when you have some sort of base, in this case it'd be 1 point whatever our interest rate is, say 13%, and then you raise that to t, your number of years that you're invested for. Okay, and the reason that this is the function that we use for percentage growth is that what happens with this 13% is after the first year, your base is actually now more money. So after 1 year of investing at 13%, you actually have more money in the account. And so then the next year it actually grows faster because you're growing 13% on your original money, plus you're also growing 13% on the money that you earned the first year. And then the second year you're earning interest on your interest, and then interest on your interest on your interest, and so on. It continues to grow exponentially, hence exponential growth. Same thing for credit card debt. If you borrow $5,000 on a credit card and then you don't pay it off, then after the first year you owe more than $5,000, and the credit card company isn't just going to charge you 30% on the original $5,000, they're going to charge you 30% on the $1,500 that you got in interest in your first year, and so on. So we're going to do an exponential regression on this because it is percentage growth. And so to do exponential regression, we go to Stat, and we're going to Calc, and we're going to do exponential regression, which I think is option 10, option 0. Yes, it is. There's option 0, exponential regression. Now, if you've got an older calculator, then you actually need to do this slightly differently. I'll show you how in a sec. But the newer TI calculators, you'll pop up with this list. The default is fine, L1 and L2. The only thing I want to change is I want to store my regression equation so that I can actually graph it. So under the vars menu, you can go to yvar and function y1, and then calculate. So, and so I'm going to hit enter here. So this line here, second quit, sorry. Second entry. There we go. This entry here, expreg L1, L2, Y1. This is what you need to do if you have an older TI calculator, like a TI-83. So when you go into the stat menu and you do calc exponential regression, it'll pop you back out here with just expreg. Looks kind of like it will look like this. And then you actually need to manually enter your lists. And you can do that by going stat. What am I doing? No, it's under vars. No, it's not. It's under list. There it is. List. There we go. I found it. Sorry. I haven't done this in a while the manual way because I've got a newer calculator. But right here, you see it says list. List is how you get your list variable. So we want list 1. Then we need a comma, which is right here. Then we need second function list 2, comma, and then vars where we want to store it, which is yvars function y1. Enter. And that does the exact same thing we just did. And if you look on your y equals screen, now we have our function. And if I go to my graph, swoop, our calculator will very, very slowly graph our exponential equation. Now, in this question, we don't actually need the graph. I'm not asking for any particular value. I'm asking for the growth rate. Now, if you remember the equation I had down here was like 1.13 to the t. This part right here is the growth rate. So if I go back to my second entry and do my exponential regression, this is the screen we actually care about because our growth rate is right here. Our growth rate isn't the base is, right? The base is what we're raising to our exponent. Our base is 1.114, which means that our growth rate is 0.114. So our growth rate is 0.114, which you multiply by 100% is 11.4%. And so our correct answer is D, 11.4%.